Everyone. Hi, everyone. Thanks for joining today's ELISA seminar introducing Basil. We're delighted to have Luigi from Red Hat. Luigi is a senior software quality engineer at Red Hat to introduce Basil, which is an open source tool for tracing requirements, code, and tests. With that, Luigi, would you like to start?
Thank you. Hi, everyone, and thanks for joining today's meeting, and thanks for Linux Foundation for this opportunity and interest in the Basil tool. My name is Luigi Pellecchia. I'm a software quality engineer at Red Hat, and I'm working on the Rivals project, acronym of Red Hat In-Vehicle Operating System. Today, we are going to introduce Basil, a tool aimed to quality department of companies involved in functional safety, but also more in general, quality department of software companies that need to provide evidences about the software specification analysis and test coverage. Before moving forward, if you have any question, please write in the chat. We will keep last few minutes for Q&A. Why Basil? So today, comply to safety standard imply a great effort for quality department. As quality engineer, we have to produce different work items like requirements, test specification, test cases, test reports, and we need to provide evidences and traceability for internal and external audits. So usually that happens across a complex tool chain that involves several tools and different file formats. So having the data organized the proper way can help us on keeping the situation under control and having anytime the great picture of the status and what remains to be done. So what is Basil? Basil is a tool developed to support the analysis of a software component specification. A software component can be a single function, a class, a library, or a functionality scattered across multiple libraries. And it will drive the user in the development of different work items, as we will see soon, like software testable requirements, test specification, and test cases, highlighting during the way the coverage of the software specification and ensuring an exhaustive analysis. This tool was presented to ELISA community last June during a workshop in Berlin. And thanks to the interest of the community, we are going to publish it as an open source project in the ELISA GitHub repository. So stay tuned. At Red Hat, we used Basil to analyze glibc API that were in our safety scope. On doing so, we used man pages as a software specification, and we derived testable requirements from them. Thanks to this approach, for example, we identified also gaps in test coverage. Let's see how Basil works. So first of all, following a natural workflow of analyzing a complex specification, Basil will work with a snippet of the document at a time. So we are going to decompose a more or less complex specification document into multiple snippets to be able to justify them or to create relationships to work items we need to produce and maintain as part of our quality management system. Basil will support as a starting point following work items, software testable requirements, test specification, test cases, and other justification. Test specification in Basil are intended to be a description of the test maneuver, and the test cases is intended to be the implementation of that maneuver in the real implementation of the test. So let's take a look on fields that we can populate for each work item. This is just the first proposal. For other justification, we have just a description. For software testable requirement, we have a title and description. For test specification, we have a title, preconditions, test description, and expected behavior. And for test cases, we have a title, description, repository, and relative path. This set of fields is just a starting point, and we will extend it going forward. Before going into the details of the tool, let me say that Basil is developed in a way to support a different workflow. That's because not all the companies will need to produce all those work items. So an example can be, even if it's not common, can be a software specification already written with all the formalism that are required for a software requirement. So in that case, a company can avoid to create and maintain software testable requirements at all. And Basil will support this scenario. Another example is a company that don't want to produce a test specification because, for example, their tests are written in a behavioral environment that is self-explanatory. So in that case, I imagine the company will generate requirements and test case only. I know that in the picture, we are missing some work items that a quality management system will require and support. Let me say, for example, test reports. For test reports, that was intentional, at least as a starting point, because test reports are strictly connected to the company infrastructure, and I prefer to see different use cases to understand what level of abstraction best fit this tool. Let's see which kind of relationship we can generate in Basil for the above mentioned work items. We have essentially two types of relationships. Direct, that means a work item is directly connected to a snippet of a software specification. For example, a testable requirement connected to a snippet of the software specification. And indirect, that means a work item is connected to another work item of a different type. For example, we can have a test specification connected to a software requirement that is mapped against a snippet of the software specification. In Basil, such relationships are not generating a link from work item to another, but from a work item to the relationship of the top level work item with its own parent. What does it mean? The same top level work item can be connected to different snippets, and each instances of that work item can be related to different set of low-level work item. That's because an high-level work item has a software requirement, in general, can describe a behavior that is scattered in the specification across different snippets. In that example, we have a requirement X mapped against two different snippets, and it's possible to have a low-level work item that just describe a behavior related to the snippet 1. For example. Anyway, no one forbids us to create the same set of work items to multiple instances of a software requirement or a software specification and so on. So direct and indirect relationships are itself the work items that host data. So direct relationship will be characterized by section, offset, and coverage percentage. And indirect relationships will be characterized by parent relation ID, child work item ID, and coverage percentage. We will see better soon. As we saw, we support also a kind of work item that is just justification. Why we need it? In that way, we can assign a meaning to each snippet, even if it's not possible to relate it to another work item type. That also to ensure completeness in the specification analysis and to provide evidences that everything is under control. So, as described before, each relationship defines a coverage percentage. That coverage is intended to be unique. That means that the overall coverage of a work item is calculated as a coverage sum of its children. All the coverage data is propagated from the bottom to the software specification. This way we can follow progress and highlight gaps. So one thing that for sure a quality department like to keep under control is work item histories and versions. So in Basil, each work item doesn't live alone as a silos, but is anyway connected to something else. The only thing that is out of this logic is the software component itself. And moreover, the relationships is not just a link, but is something that hosts data, as we just saw. So is itself a work item, and we'd like to track any changes to any kind of work item. That's because we'd like in future to be able to generate baselines, or in other words, we'd like to take a picture of the set of work items at a certain point in time. That's to be able to refer a baseline to a particular release and so on. With that in mind, it is clear that a version of a software requirement mapping a snippet of the software specification will be the combination of the version of the software requirement and the version of the relationships. The same logic can be applied to other work items. So to be able to track the history, for each table that we have in the database, we defined an history table, another additional table. So adding a row in a table, we will use event listeners to populate and edit history table as well. So for example, to know the current version of something, we will query the database looking for last version of the work item and the last version of the relationship. So we will see version number like 4.2, where 4 is the version of the work item and 2 is the version of the relationship with its own parent. So, as I said, in general, companies that are trying to reach high quality standards need to implement a complex toolchain. So probably your toolchain, you are generating some data with a tool X and reusing that data with a tool Y. That the tool will generate another data that you will use for other purposes in a tool zeta and so on. So Basil goal is not to cover the full tool chain, also because test infrastructure can be very different company by company, but to easily be integrated into any other tool chain. On doing so, Basil will provide a web REST API, and moreover, will implement SPDX data import export to simplify the interaction with SPDX based tool chains. Let's see an example of automation that we can implement around Basil. So imagine we are going to test a software component. We can use Basil to retrieve via REST API a list of applicable tests, and we can use our toolchain to trigger such tests in our test environment. At that point, we calculated and updated test coverage, and we also have test result. So we can store test result in our database, and we can update Basil with the new calculated test coverage. Finally, we can use failures to list requirements affected by failures, and we can list requirements with gap in test coverage. So Basil can help in that kind of scenario. Another possible automation is related to a merge request to the software specification repository. Imagine we are storing such documents in a Git repository. So once we merge changes in the default branch, we can trigger a pipeline job to ask Basil to list all requirements affected by such changes. That's because a change in the software specification will break some links in Basil, and we will be able to identify work items with broken links. And starting from that, we can open task and work on such kind of requirements and fix test cases and so on. Before seeing a live demo of the tool, I want to talk a bit about technology used by Basil. Current version consists of 2 projects, a front-end web application written in Python 3 using Flask as framework. Front-end is also based on HTML and JavaScript to handle the user interface. And the second project is a REST API written in Python 3 using Flask and Flask Course as frameworks. And we have an SQLite database that is handled in the REST API project using a Python object relational mapping framework that is SQL Alchemy. At Red Hat, we are working with the user experience team to implement a better user interface for the front-end application. So we are going to switch to a React-based front-end web application that will use Butterfly as a framework. This is an ongoing effort, and I will show both versions later. Current version architecture consists, as I said, of two projects. So essentially a front end that in the current version can be executed running app.py script available in the app directory. In the next version, we will move to a React-based project, so we will run it in a different way using probably NPM. And the second project is a REST API that will be the same in the next version that can be executed running api.py in the API directory. As it is possible to see in that slide, the only project that can interact with the database is the REST API. So user will be able to interact with data via front-end or via REST API directly. And REST API is relying on table models, so an abstraction of a database table defined in DB models directory. So I added it here because it will be easy to understand that if we want to support new work items, we have to start adding a file in this folder. And okay, let me just add something about well-known incoming improvements. We know that we are going to move to React Patternfly as front-end application. We'd like to implement baseline to be able to save a set of work item version at a certain point in time. We'd like to implement comments for each work items because this is intended to be a collaborative tool, and comments will speed up the review and will increase the quality of work items. And we want to introduce assumption of use as a separate work item. Today, we can add assumption of use as other justification, but creating a dedicated work item will simplify data collection and report generation. Contributions, which kind of contribution I'm looking for? So let me say any kind of contributions. To be more specific, anyone is welcome to contribute in Basil. You can work on coding, testing, documentation, anything you like. Another important thing that I'm looking for is a use case. We'd like to have other projects involved, but because using the tool will be the best way to identify improvements, opportunities. So it's time to see a live demo of the tool. So just a second. So today, Basil, current version of Basil have this kind of view. So we have essentially two pages. The main page that is a list of software components divided by libraries. So here you will see 3 different libraries. So dummy data, so don't mind about the data. But just to understand, we have software components. I added glibc API from ByteOrder in each in those sections. And you can, the main interaction with the tool will be via a modal view that will be highlighted, moving and clicking around on buttons. So to add a new software component, essentially you have to file this form. It's also possible to do via REST API as well, if you want to automate some initial population process. And for each software component, we can see also that we have a version. That means something changed in the description. We can see in a history, clicking on the history button. So for example, I changed in the version to the library name. And we can modify data from here. This is the current version. So that is a Python 3 based front-end application. So let's see what we can do going inside an API. So for example, for HTML, where I use the man pages as a software specification. So you will see a table split in two sections. On the left, we have software component specification, and on the right, we have software requirements. That's because here we highlighted this particular view where the direct object that we see is a software requirement. But we can move to different pages. For example, I want to see the mapping against test specifications or against test cases, and we will show, I'll scroll the window later to see the content. So let's come back to the software requirement section. Software requirement, as we said before, we can create a link from software test specification and test cases to software requirements. So we can hide or view indirect relation using those switches. So essentially, you can see in this view all the mapping. So essentially, this section highlighted in the map page, that is just the header of the map page itself, is surrounded by this shape. That means it is a work item type justification. And you can see the meaning of this section is just the map page header. So essentially, you can see the history of this component. You will see version 1.1. So you can be able to edit it and delete it. And same for other boxes that are gray. The pieces that looks like this way are pieces of the specification that have no justification at all at the moment. So it's something someone needs to look at and justify creating requirements on justification and stuff like that. And for example, here we see that the description of that API is assigned to different work items. So let me say, just before moving into this detail, that for example, this section that refers to different API is justified to related to other API, and just to explicitly say that is not relevant for the analysis of this software component. So coming back to this requirement in particular, we created a requirement. You can see version 1.2. So something changed into the mapping. We can see the coverage, for example, I changed, and you can see the history. You can assign a test specification or assign test cases. From here, you can see all the details. So essentially, we used a different formalism to create a software requirement using such kind of formalism like show and so on. So what is mandatory for this kind of work item. And we assigned to these software requirement two different test specifications. So a description of test maneuver. So let's see, for example, this. We want to test, for example, the conversion on a system that is a big endian. So we have a precondition that the system should be big endian, and we have a description of the maneuver and unexpected behavior. That is just a top-level description of what a test should do. And someone else can implement the test, or we can have an upstream test that we want to link to that test specification. So scrolling down the view, we will see, for example, other requirements where we don't have any other indirect object. Let me just show you how it's possible to hide in the view indirect relationships. And moving to test specification, for example, we can see that in the view of the test specification, I added a relation from a test case, an upstream test case, to this test specification, because I know that upstream we have a test for GBC that is covering that particular test specification, and I want to have this mapping here. So I know which kind of coverage this test will provide to this specification, and I reported it here. So let's see, for example, this test case is hosted on the repository, and this is the relative path. So this way, using this combination of information, we can be able to run this test in some test environment as well. For example, the repository can be also a local path, and the relative path should be just the same. And okay, more or less that is for what I want to show to you to the man page as a test specification. I want to share another possible use of this tool using the source code itself. We have, for example, for H2NL, I use it as a software specification of the source code of the implementation, so the implementation file. And I want to map on top of this file itself test cases, for example. So in the view of the requirement, I don't have anything. But another important thing is that you will see justification on all the pages, and you don't have to create it in all the pages. No, it's just a justification that is used for all the possible view. So if we go in the test specification view, we can see that I have a test specification for this branch of the if that of the implementation, and a test that is covering this section. And we have another test specification covering this section. So if I go into the test case view, I will see only test cases mapping the same thing. So what I want to highlight here is that this way we can highlight a piece of the code that it's possible that are not needed at all, or a failure in the implementation, or we can discover that our requirements are not covered, or the implementation is not matching with the software requirement, and so on. So, and the same way we can provide, we can track the progress, because we know that we have a percentage of the page that is not mapped against anything. And so we can use the REST API to know, to track progress in other tools, for example. Okay, let me show to you how it is possible to create such a relationship. Essentially, you can select a piece of the code and you can click one of those buttons to create a relation. Let me say, for example, I don't know, justification. So the section will be automatically populated, and the tool will calculate an offset where this piece starts. That because, as per my experience, software specification can have some key text highlighted and reported multiple times. So to be able to identify the right section, we need an offset. And then here you can populate the justification you want. The same way you can do for other work items, like, I don't know, test cases. So you can map against an existing test case or a new test case using that. And you can specify a percentage of coverage in this field. So this is essentially what is the current version. Let me show to you also the REST API. So we have, sorry for moving around, but this front end is running on my laptop on the port 8005 and is communicating with a REST API that is running on port 5005. So essentially from here, we can read data of different types. For example, this is the list of API that are related to the library glibc, essentially. And we are reporting all the information we need. The same will be done for all other work items and relationship. We have an URL for everything. And you can communicate with the REST API using all the HTTP verbs. So get is to read, post to create a new item, put to edit an item, and delete to remove it. So let me show to you also the next version. So the one that is using Patternfly, thanks to our UX team that did a great effort in a very short time to provide this to be able to show to you today. And so essentially, this, as I said, this is using a Patternfly as framework. Patternfly is an user experience framework provided by Red Hat and is an open source project. And so essentially, you here we see the same list of libraries that we have in the homepage of this version. Essentially, those are reported here. So we will have several values here. And for each library, we will see all the APIs. And so here you can create a new API, and you can see details of an API, for example, opening it this way. You can update data directly from here. And so this is the overview. So this is Patternfly is a responsive framework, so it will be adapted to your screen automatically, and you will be able to see it also on a smartphone, but even if it's not the desired use case. But yeah, in general, you will be able to filter using text box and so on. So this is the incoming improvements we are working on, and I hope to show to you in the next workshop that we will have in Munich next month a version completely based on this framework. I think that we can just a second navigate the code together, and then we will leave space to questions. So we have in the Basil the repository that is not ready yet in the ELISA GitHub, but I hope that for the next webinar in Munich we will have it, and we can share details in that during that workshop. So essentially, we have two projects, API and app, and then we have the DB folder. So in the DB folder, we have models where we have for each work item, so we have and the relationship, we have a file that is implementing SQL Alchemy syntax to generate and to populate a table in an SQLite database. So more or less, those are more or less similar files. Database is that basil.db. Inside the DB folder, you can access it using simply using. Sorry for that. SQLite, so you can list table, for example, and yeah, and you can see schema of each table, and so on. So it's possible also to log in into the database and see data inside it. The app project, now there are a lot of files to support Patternfly, but the main project for the current version is app.py. So it is a Flask-based and is essentially supporting two root, that is the index, to show the view of the list of libraries and APIs that is relying on api.html template that is inside the template folder, this file, and a mapping root that have the API ID inside the URL, and that is relying on the that is reading data from the REST API using a GET request, and is providing the data using a template file named mapping HTML, that one. We have also an help table page, but it's not used at the moment, so it will be used once the repo will be ready to report relevant information. The API file is a bit more complex. It's a bunch of thousands of lines. Yeah, and essentially is handling those routes. So those are URL that you can access using different verbs. This is the syntax used by Flask. And there is also the logic to generate the mapping against work items and the software specification. And there we have an SPDX manager that is the file aimed to generate SPDX data import and export. Okay, I think that is all from my side as overview of the tool. And if anyone has any question, please let me see. I'll try to restart my video.
Thanks, Luigi. I did post in the chat. You mentioned that there'll be a session on this tool at the upcoming ELISA Munich workshop. So for those of you on the call today, I just posted the link to the ELISA Munich workshop. So obviously there's the session on this tool that Luigi is going to dive deeper into, but there are number of other sessions as well. So if you're interested, details are there and it's free, and the registration form is on that page as well.
Yeah, you're right. We will show updates in Munich, and yeah, I hope to arrive to that workshop with the repository populated, so people can start using the tool and start some contribution and discussion around to understand if it's something that fit other needs, and how we can use it for functional safety in particular. Okay, last question to you is that you will publish the recording on the ELISA website?
Well, yes, we will get the recording out to those who registered to attend the seminar, but somehow missed it. And we'll also upload it onto the ELISA seminar playlist on the ELISA YouTube channel.
Okay, I'll share also slides if it's possible to store
That
it
would be
on the
great.
website. Okay.
Yes.
So if there is no questions, I can.
Luigi, may I ask a question?
Yes, please.
Okay, yeah, so Lucas Ulban speaking here. Have you already thought about the challenge of maintaining this information when man pages or source code is modified?
Yeah, yeah, it's something that is in my mind. Yeah, it's something that we need to handle in some way. Essentially, you will see that API can be API stores also a library version, and so essentially you can a first way that comes in my mind is that you can update the versions, because you will keep the history of all the work items. So if you want to refer to the version 2.33, for example, you know that the version in Basil, the Basil version X is related to that, so you can retrieve information for that particular version. At the same way, when, for example, if you use the source code and something change, what happened is that, let me see, for example, this link will be broken. So you will see this specification listed in a separate table to say, pay attention, this test specification starting from the version of the library 2.35 is broken because something changed in the code and is not matching anything. So you need to rework it because that can mean that something changed in the test because the behavior is different in the implementation, or simply you have to remap against the correct section, but you have a track of everything using versions. So let me say it's something that you can keep under control. The only thing that needs to be done is to simplify the access of such kind of information from the API, for example. So I imagine a simple way when you can ask to the API, give me all the requirements or the test specification for the version X, and or the delta between X and Y. So that will be something useful to implement and to see. Yeah. Thanks for the question. I hope that answers your questions.
Yeah, thank you. Thank you very much.
Other questions?
You can also type your question in the chat if you are shy about asking verbally.
Yeah, it's not, don't be shy, it's not, the aim of this presentation is to understand if your needs, if this tool match your needs, your expectation, what you are doing in your company, because we need to work with such kind of work items, things, and provide such evidences. And so the idea is to provide an open source tool that can help us in that direction. So I'm sure that anyone have a different scenario, so it's possible that anyone can share his experience and see what we can do in Basil to support. But anyway, at the end of the slide, you will see also my email. Let me share to you also in the chat. If you have any questions, you can also send me an email, or you can reach out to me on LinkedIn. Is the same. And yeah, thanks for attending the meeting, and thanks once again to ELISA for having me today.
Yeah, thanks, Luigi, for giving the talk.